Our last lesson we looked at growth and decay, which is our starting point for our equations. On this one we'll look at exponential growth and decay. And this is more of how we use our loans. If you hear someone talk about APR or something along those lines, they're talking about exponential growth, and this is how they determine your interest on things, either paying or getting it. We'll first look at our equation. A equals P times E to the power of RT, and our E is a number, and I'll write out the first few digits of E. It is an irrational number, so this will go on forever, but it will be 2.71828. And this is a number that we'll see again and again when we look at natural growth or decay with the population in cities, with doubling or anything else. It comes back to 2.718. Our capital A is the n amount, and I know we had A on our last equation on growth and decay as our starting amount, so we need to pay attention if it's capital or lowercase and where is that. P is our beginning amount. This usually stands for principal for our finance group. R is our growth or decay rate. Again, if its growth is positive, if its decay is negative. And T is time, and we need to be very careful on how we are using our time, if it's years or months. Our first example, credit card debt. This is a common problem for most Americans, so I want to give you an example of how you can find out how much you're paying and how long and on what time scales. So the natural average APR is 14.90. This is the average principal percent rate per year on a credit card. If you owe $10,000 and are planning on paying it off in 5 years, how much will you owe in interest? And I took this data from the creditcards.com for the natural average. So what we'll have is A equals 1,000 times E, remember that is a number, our rate, we're going to divide it by 100, giving us 14.9. I don't need to write the extra 0 there, it's just extra. And T is 5 years. And so when we plug this in, we'll see that we have, and so if we plug it into our calculator, we'll see that we are paying $21,064. So in 5 years, you're basically paying the half of a medium salary for the American. So in 5 years, you're basically paying half of a medium salary for the average American, depending on your education and everything else. So this is why not getting into debt is extremely important. Most of y'all are looking to get a new car in the next several years. So we're going to look at getting a new car. We use the average for our loans and how much a car would cost. A new car would be $33,560, and we'll assume that you've saved up $500 for the card, and you decide that you want to take a 60-month loan out at 4.51% per year. Again, these are all real numbers that I found on the online for 2018. How much more? So we'll look at how much more will the car cost at the end of the loan, and what will your payments need to be to pay it off in 60 months, assuming that we'll apply the interest once at the start. The reason we do that is to make it easier on ourselves. The way they do it is every month they reapply the interest, so it's a little bit more complicated, but at least this way this gives us an idea of what we're paying for. So our first question is how much more will the car cost? So we're going to plug it in. We have A equals P, which is going to be $33,560 minus $5,000 for the down payment, and so that will give me $2,856 times E to the power of a loan, which is 0.041 times the amount of years we have, which will be 60 divided by 12 is 5, so this is a 5-year loan. When we plug this in, we'll get a number of $35,784.20. We're going to leave the 20 cents off. And so looking at this, it only costs $2,000 more, but we have to remember that we've already put that $5,000 in. So really it's going to be $7,000 more. Okay? And you can also try it without the $5,000, see how much more it would cost. And now to find out what we have to make the payments on, we'll divide it by 60. So dividing this by 60, we would be making $594.40 per month. So I'll just say $600 per month. So to buy a car like this, we're paying $7,000 more to pay over 60 months, and we would be paying at $600 a month, which